Hello. In this video, I will take this sequence here, half, quarter, 1/8, 1/6, and so on. I will generalize this idea into a more general kind of sequence, but a sequence that has this feature that you always get the next number in the sequence by multiplying by the same number. So just as an example, let's say the first number in this sequence is 2, and suppose that I can get the next sequence by multiplying, say, by 3. Okay, so 2 times 3 is 6, and then I get the next number by multiplying by 3 again. 3 times 6 is 18, and so on. Okay, or like in the previous example, my first number is half, and I get the next number by multiplying by half to get 1/4. Next number times half. Next number is obtained by multiplying 1/4 by half. That gives 1/8, and so on. So this is the kind of a sequence that I want to talk about. Now, this kind of a sequence has a name. It's called a geometric progression. Now, the short form is usually GP. Right? So if I say GP in mathematics, we nearly always mean geometric progression, at least for A-level mathematics. Okay, what I want to do in this video is to find some formulae for this, like I did for AP. So I like to find a formula for, say, the R term. I like to find a formula for the sum to N term. So to start off with, let me represent the numbers in this sequence by some symbols. So I'm going to let the first term be A. Okay, so A is going to be the first term. So here will be 2. Here the A would be half. Now the next term, in these sequences, I got each term by multiplying the previous one by the same number. So in this case, it is always 3 times this, and that's to give this, and then 3 times this to give the next one. So let's say that number, I'll let that number be R. So to get the next number from A, I multiply A by R to give AR. And if I multiply this by R again, I'll get the next number, so that would be AR squared. And so on. Okay, and R has a name. The name for R is called common ratio. Ratio in the sense that if I divide this by this, I get back R. And it's common in the sense that if I divide any one by the previous one, I always get back R. Always get back the same ratio. So the ratio of every 2 adjacent terms is always the same. Okay, and let A be the first term. Okay, so what I like to have now is a formula for a general term. Let's say, okay, I shan't call it the rth term because I've already used the symbol R for the common ratio. So let me call it the ith term. So I is just a number, so like maybe the 4th term or 5th term. Alright, so for example, okay, the ith term, if you're seeing this for the first time, it looks a bit odd. But let me just write down an example. So for example, if I say okay, I is the order of 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 a term. So for example, I equals 3 means that we're talking about the third term. Okay, right. So for the ith term, I want to know what the formula is. Now you can see a pattern here. Let's say when I is 1, we have the first term, right? When I is 2, we have the second term. I is 3, we have the third term, and so on. Now notice something. When I is 1, there is no r. When I is 2, we have just r, which is the same as r to the power of 1. When I is 3 for the third term, the power of r is 2. So this means that the power of r in each term is always 1 unit less than I. Okay, so 1 is 1 less than 2. 2 here is 1 less than 3. So if you're talking about the ith term, then the formula should be ar to the power of I minus 1. The power of r should be 1 unit less than I. So this gives us the a formula for the ith term. Now I'm going to represent the ith term, the value of the ith term, by the symbol ti. So ti would be the ith term, the value of the ith term. So, and we have seen the formula here already. So the ith term has this formula: a r I minus 1. So that's the formula. Okay, so the ideas that I'm using here is pretty much the same as what I used for AP. Okay, the next thing I want to look at is the sum of this. Let's say I have a certain number of terms for the whole sequence. So this time I'm not going to talk about having an infinite sequence, at least not yet. So for now, suppose that this sequence goes on until I have n terms in the sequence. So for the last term, which I'll call the nth term, let's say this is a sequence with n terms altogether. Now n is just a number. For example, n can be 10. So let's say this is a sequence with 10 terms. In fact, it might be easier if I put in an actual number for the n. So let me just say 10 terms. Okay. Let's say this sequence has 10 terms for a start. Then the last term in terms of a and r should be a times r to the power of, right? We know that the power is always 1 unit less than the ordering of the term. So if we are talking about the 10th term, the power of r should be 10 minus 1, which is 9. Okay. So that's the 10th term. So if I have a to the power of r, now if I a times r to the power of 9, this would be the 10th term. And if the sequence stops here, it means that I have altogether 10 terms in this sequence. Okay. So now let me make this more general. So let's say it doesn't have to be 10 terms, it can be 20 terms or 100 terms. I'm going to represent the number of terms by n. Okay, so write this out. N is equal to the total number of terms, right? Total number of terms in the sequence. So if that's the case, then I would change the 10. I would just say n terms instead of 10 terms. So this would be the nth term, and the power therefore would be n minus 1. So ar to the power of n minus 1 would be the nth term.